All right, good morning or good day, wherever the time you are watching this video. The topic we are looking at is direct variation, and we'll be looking at all the necessary aspects we have to understand as far as direct variation is concerned. Direct variation is a subtopic under variation. We have other topics like inverse variation, joint variation, and partial variation that will be considered in the next video. So we are going to make a video on uh, inverse variation, joint variation, and partial variation. So for now, we are looking at direct variation. So let's continue. We have it here as the definition. Its direct variation describes a simple relationship between two variables where one is a constant multiple. Look at that word, where one is a constant multiple of the other. That is, as one variable increases, the other increases at a proportional rate. So that's something we have to look at properly, at a proportional rate. Okay, all this will be understood as we proceed in the with the topic. But there are some terms we have to just understand properly. Anywhere we see letter K, as far as variation is concerned, especially direct variation, K represents constant. So which means we can't have any other variable as letter K. K remains the constant of the variation. So directly proportional, we can call it varies directly, or directly proportional uh, is just a kind of synonyms by saying varies directly or directly varies. Also on the graph, a direct variation graph is always a straight line. That is, it passes through the origin. It passes through the origin. So let's proceed with examples to make this clear. Now let's look at one or two examples. Now, before we move on, when any question is given to us in direct variation, there's something we just have to know or we have to calculate. Either we are told to do so or not. That is the constant. There's no way you can proceed with your calculations in direct variation without calculating the constant. And here I'm going to start by how we can find the constant. After that, we move to how we can describe the relationship by writing an equation for it. So if we are told to do so or not, this is also necessary. It will make our calculations very easy. Then the third aspect is how we can now calculate unknown variables, having known the constants and having described the relationship with an equation. So let's take it one after the other. Here we are asked to find a constant. We are told that y varies directly. So I'm going to write this. Y varies directly as x. So let's denote it this way. Y varies directly as x. I'm going to write it like this. Y varies directly as x. Then we are being told that y equals to 15. So anywhere I see y, I'm going to put 15. So I'm substituting variable y with the value given to us, which is 15. So y varies, I'm still using the sign of directly varies here, or the varies, I'm using the symbol. I'm going to change it later to equals to. So 15 varies as what? X. X is what? 3. But before we proceed, if we have it this way, you'll be wondering, what am I going to do? 15 varies as 3 or 15 equals to 3. Something is missing, which is what we want to calculate, K. So that means by the time we describe the relationship, with this kind of equation at the upper part here, we are supposed to add our constant, which is constant k. So which means here now, after having our 3 here, the k will also be here. So this makes sense now. 15 varies as 3k. Then directly here now we know what we have to calculate. 15 varies as 3k. Now I can change the symbol to equals to by saying 15 equals to 3k. And of course, when we have something like this, it can also be written as 3k equals to 15. Nothing changes here. No sign is being affected. I'm just interchanging the right to the left, the left to the right. So 3k equals to 15. Now we are going to divide both sides by the coefficient of k, which is 3. So divide both sides by 3. If I cross out this now, 15 divided by 3 will give us 5. So that's how we have our constant to be 5. So calculating the constant is very important and very easy. And one thing is this: once the constant is wrong, everything is wrong. So we have to make sure we get the constant right. So let's look at the second example, where we'll be asked to describe the relationship by writing an equation, which is also very important. Now look at this now. We are being told that the distance a car travels varies with the time it spent driving. Now we can denote the letter, we can denote distance with letter D and time with letter T. So don't forget, distance letter D, time letter T. So let's proceed. The distance a car travels, so I'm writing D now. That D denotes distance. Varies, I'm using the symbol directly with the time. So D varies directly with time. Don't forget, we have to add something like we did when we are calculating the constant. So we add our what? K. So D varies directly as T, then we have our K. If a car travels 120 miles, when we have miles, kilometers, meters, and so on, we're talking about distance. So that means where I have D, I'm going to change that D to 120. So varies, 120 varies directly as the time now is 2 hours. So 2k. Then I can simply write it as 120 equals to 2k. And like we did earlier, we can say 2k equals to 120. So what are we going to do next? We are going to divide both sides by 2. We divide both sides by 2. And after doing that, then we find the value of k to be 60. So k equals 60. What we have done here is just to find the constant. So our constant is 60. Then we go back to the question now. We want to write the equation for this, for the relationship between the distance and the time. So I'm going to use this part of the work we have done. Let me make it a different color. I'm going to make use of this. You can see that on the screen. I'm going to take this now and write an equation with that. So let's proceed. Let me just change that color now to a black one. Now I'll be having D varies as TK. T, don't forget, TK means T multiplied by K. In mathematics, when you have AB, AB means A multiplied by B. If you have 2x, 2x means 2 multiplied by x. So TK here means T multiplied by K. But it won't really make sense to write T60. Normally in mathematics, we have the number coming before the alphabet. So, but let me make it like this: T open bracket 60. So that simply means T multiplied by 60. And when we do that, that will give us G varies. T multiplied by 60 will give us 60T. So you can write your relationship like this. It's very correct. And also you can change the sign of varies here and write your relationship as G equals to 60T. That is absolutely correct as well. Now let's now look at the third example, where we are going to make use of the three steps, that is finding the constant, writing an equation for the relationship of the variables that we have, and lastly finding or solving for the unknown. So let's take it one after the other. Now here they said suppose y varies directly as x if y is equals to 10. So let's start with that. Y varies directly as x. Then we have the constant. Y is 10. 10 varies as x. X is what? 4. Then we have our 4k. And I can say 4k. It's not a must to do this. You can divide both sides directly by 4 at the second step. But I just like to have my, my constant, the alphabet I'm trying to calculate at the left hand side. So that's why I'm interchanging it. So 4k varies directly as 10. Then I change this sign to 4k. Sorry. So I change the sign here. Okay, let's proceed. I'm just trying to change it. Okay. So we're having 4k equals to, I'm changing the sign now to equals to 10. So now we are going to divide both sides by the coefficient of k, which is 4. So divide both sides by 4. Divide both sides by 4. So when you use your calculator, 10 divided by 4 should give you 2.5 if you are using decimal fractions, or 2.5. So but let's make use of decimal fraction in this calculation. So k equals 2.5. Okay, we found the constant. Now let me change the color of the pen to blue. Now we want to write the relationship as an equation. I'll be using this part, like I said earlier. I'll be using the parts we have here, and that will just be y varies as x k, but our k now is 2.5. So let me say 2.5, x into bracket 2.5. That means x multiplied by 2.5, and that can be rightly written as y equals to 2.5x. 2.5x. So I'm done with the equation. Then I will now go to the last part of the work. So let me change that, the color of that, to show that each step we're having a different color. So let's go now. I'll be using a black ink now. What is the value of y when x is 12? I will simply bring out the equation I've described here, which is y equals to 2.5x. So Find the value of y when x is 12. Y equals to 2.5. 2.5x means 2.5 times x. So 2.5 into bracket x. And my x now is 12. So y equals to 2.5 times 12. What is 2.5 times 12? That gives us 30. This is something we can do without a calculator. And how can we just go about that? If you are saying 2.5 times 12, let me just do it in a rough way here. We can have it as 2.5 times 12. Then we can say 2 times 12. 2 times 12 will give us 24. We are left with 0.5. 0.5 means half. So half times 12 is 6. Then you add it together. So the first part is 2. Multiplying the whole number, multiplying 12 gives us 24. Then the fraction part of that 2.5 is 0.5, which is half. Half multiplied by, you should know that half multiplied by 12. When you cross it out, 12 in 2 in 12, that will give you 6. So that's how we got 6. Then we add it together. 24 plus 6 gives us 30. So that's where the 30 comes from. And if you look at the answer here, the y derived is what is 30. So that's just how to go about direct derivation. So let me look at the next question here. You will be, I want you to try this by yourself. You can pause the video, attempt this question, then the second question as well. You can attempt second question as well. So after this time out, I'm going to show you the answers. So don't forget the first question and the second question. Attempt it and let's look at what the answer is. So look at these answers, the solutions for question 1 and question 2. So the question 1, the answer you're expected to derive is $84 if you have followed the step carefully, and the answer you are expected to derive for question 2 is 35. So let me just show the workings for question 1. Because of time, I might not do that of question 2. So let's look at question 1 together. The answer derived here is $84. So let's see if we are also going to get $84. So let me. So let's see if we are going to get the $84 as well. So let me just write the answer here. The answer derived is $84. So let's see if we are going to get that as well. So now, the cost of fabric varies directly with the number of yards. So let's call the cost C and the number of yards Y. So the cost of fabrics varies directly as the number of yards. Then we have our letter K. So if 5 yards of fabrics cost $35, now you have to be careful here. Don't just write 5 varies as 35K. You might be wrong. You have to look at it properly. The cost C varies directly with the number of yards Y. We have our K. Now they said if 5 yards is talking about Y, so that means I'll be having my 5 here, not under C. Now if 5 yards of fabric cost 35, cost is talking about C, I'll be having my 35. So you can see where that ought to belong. So you have to be careful when interpreting questions. So let me just go straight away and put equals to here, and we have K to save time here. And like I said earlier, we can divide both sides directly by K. It's not a must to move the K to the other side, but I just like doing that to have my own k, or the variable or the alphabet I'm looking for at the left hand side, but it's not a must. So now I'm dividing both sides by 5. I'll be left with 7 here. 7 equals to what? K. And just for formality's sake, I can say k equals 7. So I've found my constant. Now let's describe the relationship with an equation. Let's describe the relationship with an equation. And the equation now, I'll be making use of a different ink. I'll be making use of what I have here. So that will be C. Let me just make or change that sign to equals to C equals to Y, and the K is 7, open bracket 7. That's C equals to 7Y. You know, we can't have Y7, so 7Y. So I've described the relationship. Then with an equation, then I'll be using this equation C equals to 7Y. I'll be using this equation to solve my question now. If 5 yards of fabric cost $35, how much will 12 yard cost? Now we need the cost of 12 yards. So I will say C equals to 7, open bracket, the number of yards now is what? 12. So when you multiply it, C is equals to 7 times 12, 84. So the cost of 12 yards, so 12 yards will cost what? $84. So 12 yards will cost $84. As simple as that. So in case you missed any of the if you missed the second question, you can just inbox me. We can see how we can arrange to explain that, but I believe with the explanation you are not expected to miss it. But in case you did that, you can still make an attempt again after seeing the answers. The answers are displayed here. $84, I've done the first one. The second one is expected to be X is expected to be 35. So I will say bye for now. See you in our next video, where we'll be explaining in depthly the aspect of inverse variation. Also, we'll be explaining later joint variation very soon, and the last aspect of variation, partial variation. So for now, I will say bye and have a nice day.